Friends, welcome to Academic Heights. Learn from home. Why Academic Heights? You will get clarity in understanding. Crystal clear concepts will get it. We cover basics and core concepts. You will be prepared for your future competency. So overall, your turning point starts here. Already we covered 20 very short answer type questions. I will give the description above. Those who will not cover, you can see those videos. After that, you come back to this. Let us see the 21st question. Question number 21. If n is a odd integer, then show that n square minus 1 is divisible by 8. So what he has given, n is a odd integer. So first of all, I will write what he has given this one. So given. So n is a odd number. N is a odd number he has given. Then what I have to show? What I have to show? I have to show that n square minus 1 is divisible by 8 is divisible by 8. So this is given. N is a odd number he has given. We have to show that n square minus 1 is divisible by 8. We have to show that. Now, question yourself. When n is odd number, odd numbers is in the form of 2q plus 1. Why 2q plus 1? So what is the odd number? When we divide with 2, when we divide with 2, you will get a remainder 1. So that n is in the form of 2q plus 1. So this is the first observation, and it is very important point to be noted. So every odd number is in the form of 2q plus 1 or 2m plus 1 or 2t plus 1. This is already we covered in the objective questions. Next, so what I have to prove? N square minus 1 is divisible by 8. So before we do this sum, let us apply the logic. I will take two consecutive numbers. Take any two consecutive numbers. Suppose 2 into 3. The product of two consecutive numbers, 2 into 3. If I start with 5, 5 into 6. So whatever the result, this is 2 3s are 6, 5 6 are 30. This is always divisible by 2. So this is the logic we are applying. The logic is product of two consecutive numbers is always divisible by 2. So how the numbers will be? So how to write two consecutive numbers? How to write two consecutive numbers? If one number is x, other number is x plus 1. So these are the two consecutive numbers and product of two consecutive numbers. If not, if one number is x, the other number is x minus 1. Again, this is also two consecutive numbers product. So the product of two consecutive numbers is always divisible by 2. So this logic we are applying here. The product of two consecutive numbers is always divisible by 2. Very, very important. So based on this logic, we are showing that it is divisible by 8. One more logic, you know that odd numbers is in the form of 2q plus 1. So if you know these two, we can prove that this is the sum. It is divisible by 8. So let us see. So n is equal to, I am taking n is equal to 2q plus 1. This value I am substituting in n square minus 1. So when we substitute in n square minus 1, so what is n value? N value I can write 2q plus 1. Here I can write 2q plus 1. So 2q plus 1 whole square minus 1. N square minus 1. So n value I am substituting in the n square minus 1. So 2q plus 1 whole square minus 1. Expand it. You know already a plus b whole square formula. So what is this? A plus b whole square formula. A square plus 2ab plus b square. Again what we have? Minus 1. So if we expand 2q plus 1 whole square, we will get 3 terms. First term square plus 2 into first term into second term plus second term square. So here clearly 1 square and minus 1 will get cancels. Why? 1 square value is 1, minus 1, 1 minus 1 will get cancels. So what is left out? I'm writing this one. 2q square. What is 2q square? 2q into 2q. 4q square. Plus 2 2s are 4. 4q I am getting. So what I can take common in these two terms? In these two terms, I can take 4q common. It's a very, very important step. So we have 4q here. Here also we have 4q here. So if I take 4q, we have 1q extra here. Why? Because of 4q square is there. So q is extra here and this whole term is gone. I'm writing it as 1. So if I take 4q common, 4q into q plus 1. Now, so this is the logic we are applying. What is the logic? The product of two consecutive numbers is always divisible by 2. So where we got two consecutive numbers? If q is a integer, what is q plus 1? If q is an integer, these are two consecutive numbers. Look at q and q plus 1 is two consecutive numbers. So as earlier stated, x and x plus 1 is consecutive numbers. X minus 1 and x is a consecutive numbers. It is always divisible by 2. So that 4 into, this is always divisible by 2. When this number is divisible by 2, I can write it is in the form of 2 times of something. 2 times of something. When it is divisible by 2, I can write it as 2 times of some k. It is nothing but multiple of 2. It's a multiple of 2. How to write multiple of 2? That is in the form of 2k. So what I got it as here clearly, that is 8k. So n square minus 1, I got it as nk, 8k. N square minus 1 is equal to 8k. I do not get any remainder here. So that it is divisible by 8. Simply 8k, a number we are writing in the form of 8 into something. So it is clearly divisible by 8. So this is totally theory part. Just to go through it and understand it, it's a very easy if you practice 1-2 times. Suppose a is equal to bq. What do you mean by this? A is equal to bq. So a is divisible by b. I can say that a is divisible by b, completely divisible. A is equal to bq is nothing but a is divisible by b. Similarly, we got the same scenario here. Same scenario. N square minus 1 is equal to 8k. N square minus 1 is equal to 8k. It is nothing but n square minus 1 is a multiple of 8. When it is a multiple of 8, it clearly divides. It is divisible by 8. So go through once again and check it. So move to the next question. Use Euclid division algorithm to find out HCF of 16 and 28. So it's a very easy question that Euclid division algorithm we have to apply to find out HCF. First we will do by normal division method. After that we'll write the steps to avoid confusion. So here 16 and 28. So 28 is greater than 16. So we have to divide with the 16. 28 we have to divide with 16. So how many times it will go? 16 ones are 16. So what I'm getting the remainder as 12. So this division process we have to continue until you will get remainder 0. So again, this remainder we will take it as a divisor, and the earlier divisor we have to take it as a dividend. So this process continues up until you will get 0 as a remainder. So 12 ones are 12. So again I got it as 4 as a remainder. Still I do not get 0 as a remainder. The process continues. So this 12 I can reuse here. So 4 3s are 12. 4 3s are 12. So here our division stops. So what is HCF here? It's a 4. 4 is the HCF. So HCF of 16 comma 28 is nothing but 4. So we got the HCF by division. So we can write now this is in terms of algorithm also. So 28 can be written as dividend is equal to divisor into quotient plus remainder. So 16 into 1 plus remainder. So this is the first step. Dividend is equal to divisor into quotient plus remainder. Again we can continue it. So again dividend is equal to 16 is equal to 12 into 1 plus 4. So 12 into 1 plus 4. So this is my second equation. Similarly, 12 can be written as dividend can be written as divisor into quotient plus remainder. Remainder is 0. So this is third. So what is HCF? The HCF is 4. Whatever we have, the 4. HCF is 4. So this is the way we solve the Euclid division algorithm by long division method. This is long division method. If not, we can write these statements as like this. 27 is equal to 16 into 1 plus 12. Again 16 can be written as 12 into 1 plus 4. Again 12 can be written as this one. So this is the way we can write the Euclid division algorithm to find HCF. Next, show that 12 to the power of n cannot end with 0 or 5 for any natural number n. So very simple question. 12 to the power of n. In this we'll factorize 12. So what are the factors involved in this 12? So It is nothing but it goes by 2 table. 2 6 are 12, 2 3s are 6, 3 1s are. So 2 into 2 into 3. So 12, I expressed it as the product of prime factors as 2 into 2 into 3. So what is the question? 2 power n can't end with 0 or 5. To end with 0 or 5, so 12 should have prime factors 2 and 5. So we have two prime factor here. To end with 0 or to end with 5 should have 2 and 5 as the factors. So 2 is a factor we have, but we don't have 5 as the factor. We don't have 5 as a factor. So this is a very, very important reason. We can conclude that 12 power n cannot end with, can't end with 0 or 5. So think about it. If any number is ending with 0 or 5, should have two factors, two prime factors. One is 2 as well as one is 5. We have 2 as a factor, but we should have 5 also as a factor. But in 12 we don't have 5 as a factor, so that it cannot be end with 0. Next question. Without actual performing long division, find this number will terminating or non-terminating. So we'll see this whether it is a terminating decimal or non-terminating decimal. For terminating, the denominator we should write it is in the form of 2 to the power of m into 5 to the power of n. Already you know that for terminating, if you write the denominator in the form of 2 power m into 5 power n, that is enough to show that it is a terminating. In any other form, if you get in any other form other than this, that is non-terminating. So again, we should have some steps to check it whether it is a terminating or not. Step 1, whether the given number p by q number is in the standard form or not. Is it in the standard form or not? Check it whether this number is in the standard form or not. 395 divided with 10500. It's not in a standard form. Why? Because we can simplify it. So I can cut with 5 table, I can cut with 5 table. So if I cut with 5 table, 5 sevens are 35, but here I have 39. So 4 is left out, 45. So it goes by 5 table, 5 nines are 45. So the denominator, if I cut it, so 5 twos are 10, 5 ones are 0, 0. So 79 by what we got at is 2100. So this we cannot simplify further. Why? Because of 79 is a prime number. 79 is a prime number. So we cannot further divide it. So already we wrote it is in the simplest form, standard form. Next step, we'll move to the second step. Now we will write the denominator. The denominator q is in the form of 2 to the power of m into 5 to the power of n or not. We have to check the denominator. Can we write in the form of this one or not? If I write in the form of this one, it is a terminating. If not, it is non-terminating. So what is the denominator here? The denominator q is equal to, what is the denominator here? This is the denominator. Q is equal to 2100. So factorize it. 2100, factorize it. So I can go with 5 table. 5 4s are 20. 1 left out. 5 2s are 10, 0 left. Again it goes by 5 table. 5 8s are 40, 2 left or 20, 5 4s are. It goes with 2 table. 2 4s are, 2 2s are. Again with the 2 table, 2 2s are, 2 1s are. Again it is 3 table, 3 7s are. So this 2100, it is the combination of 2 power 2 into 3 into 5 power 2 into 7. So this is the combination of these many. But when the denominator, we have to write only in terms of pure 2's, pure 2 power m's, or pure 5 power n's, or 2 power m into 5 power n, not other than this. So we have extra prime factors here. 3 is other than that, 2 and 5, and 7 is also other than that, 2 and 5. So q we do not written in the form of 2 power m into 5 power n. That is not in the form of 2 power m into 5 power n. So that this is non-terminating repeating decimal. So non-terminating decimal. Non-terminating decimal. I hope it is clear to everyone. Next question. A rational number in its decimal expansion is this much: 327.7081. What can you say about prime factors of q when this number expressed is in the form of p by q? Give reasons. So what is the given number here? He has given the number as 327.7081. So it is clearly, this number is clearly, it is a terminating decimal. Terminating decimal. Why it is a terminating decimal? So in any one of the number we don't have any bar symbol, so it is a terminating decimal. So when it is a terminating decimal, so definitely q, the denominator, we can express it is in the form of 2 power m into 5 power n. It's clear that when it is a terminating decimals, we can express the denominator of the rational number 2 power m into 5 power n. So the reason is terminating decimal. What is give reason? It is a terminating decimal. That's why that is definitely it is in the form of the denominator in the form of 2 power m and 5 power n. So we can solve this one and we'll recheck it as solution. All this is a theory, we can write it by our own terms. So first of all, it is a terminating decimal. So we know that all terminating decimals will have the denominator in the form of 2 power m 5 power n. We will recheck. So after how many digits we have decimal point here? After 4 digits we have a decimal point. So this can be written as 327.7081 divided by, after 4 digits we have a decimal point, so that's why we can divide it with 10,000. Why 10,000? After 4 digits we have a decimal point. It's clearly that it is divided with 10,000. This whole number, if we divide with 10,000, we will get 327.7081. Now you cross check this one. So what is the denominator here? The denominator is 10,000. 10,000. I can write 10,000 as 10 into 10 into 10 into 10. How many tens we have? 4 tens. Why 4 tens? Why? Because of we have a decimal point after 4 digits, so those many times we have. So this 5 can be written as 10 can be written as 5 into 2. Again this 10 can be written as 5 into 2. Again 5 into 2. Again 5 into 2. So ultimately how many times we are getting? So this is 2 power 4 into 5 power 4. So 2 power 4 into 5 power 4. So whatever the denominator, whatever we have the denominator, we have expressed in terms of 2 power m into 5 power n. So this is the reason why this is a terminating decimal. So after how many digits it's terminating? So what is the highest power of m and n? So here m is equal to 4 as well as n is equal to 4. So when it is 4 after 4 digits it is terminating. Yes, you can look at after 4 digits it is terminating. So we can write it by your own these words. Try it. Last question of the day. What is the smallest number by which this is multiplied to be make it as a rational number? So this is actually irrational number. You have to make it as a rational number. So what you should multiply with that number? What number you should multiply to make it as a rational number? Find the number so obtained. So simple way. It's a very simple. You have already heard about a rationalizing factor. So what is rationalizing factor? A rationalizing factor, if you multiply with the rationalizing factor, definitely you will get a rational number. Suppose we have many forms are there. What is rationalizing factors? Suppose a plus root b. For a plus root b, what is the rationalizing factor? A minus root b. For a minus root b, a plus root b. This is vice versa. For a plus root b, a minus root b is the rationalizing factor. For a minus root b, a plus b, a plus root b is the rationalizing factor. Similarly, suppose if we have root a plus root b. So what is the rationalizing factor of this one? Root a minus root b. Simple. What is the logic here? Logic behind here. So here the signs we have to change it. This positive sign become negative sign. This is a positive sign, it is a negative sign. Negative sign, if it is a positive sign, we have to interchange the positive to negative, negative to positive. So they will get a rationalizing factor. Suppose a root b. Suppose we have here a root b. For this, what is rationalizing factor? Already a is a rational number. Here a is a rational number. For root b, what is a root b is a rationalizing factor. For root b, for root a, what is rationalizing factor? Root a. Similarly, a root b, what is rationalizing factor? Root b. So these are the some forms I have given of rationalizing factor. So we will apply for this question. So we have many forms. Suppose a root b plus c. What is the rationalizing factor? A root b minus c. A root b minus c. If you multiply these two, you will get it again a rational number. So what is rationalizing factor? When we multiply this number to the given number, the product ultimate result is a rational number, will get it. Means irrational number into another irrational number, we are getting a rational number. So here this is nothing but a rationalizing factor. So for this question, root 5 minus root 2, what is the rationalizing factor? Root 5 plus root 2. So multiply it. This is in the form of a minus b into a plus b. So what I can write? A minus b into a plus b. A square minus b square. So a square, first term square minus second term square. So root 5 square minus root 2 square. square and square root get cancels, square and square root get cancelled, so I got it as 5 minus 2. So what is the value of 5 minus 2? That is 3. 3 is a rational number. So that simple, the given irrational number, what we should multiply, ultimately you will get a rational number. That is rationalizing factor. I have given so many rationalizing factors. Just keep in mind that change in sign, change in sign, you can easily modify to the rationalizing factor. So hence that's all from my side. I hope it is clear to everyone. If you have any questions, you can comment.